Have you ever wondered why some engineering problems feel unnecessarily complicated? The truth is, sometimes the difficulty lies not in the problem itself, but in the way we choose to look at it. In physics and engineering, choosing the right coordinate system is like choosing the right tool for construction. You wouldn't use a hammer where a spanner is needed. Similarly, you shouldn't force Cartesian coordinates on problems where symmetry suggests a better choice. Cartesian coordinates, x, y, and z, are the default. They work beautifully for rectangular structures, beams, and most architectural layouts. Civil engineers often rely on them while designing floor plans, trusses, or bridges where straight lines dominate. But what happens when we move from rectangles to curves? Imagine designing a cylindrical water tank, or analyzing stress in a tunnel arch, or even modeling the vibrations in a circular foundation. Suddenly, Cartesian equations become clumsy. That's where other coordinate systems step in. Polar coordinates allow us to describe any point in a plane using just a radius and an angle. For problems involving circles or arcs, this reduces complexity dramatically. Cylindrical coordinates extend this idea into 3 dimensions, perfect for analyzing structures like chimneys, pipelines, silos, or domes. Instead of juggling multiple x and y terms, equations become cleaner, more symmetric, and easier to solve. And for even greater symmetry, spherical coordinates prove invaluable. Civil engineers may not often design spheres, but understanding them helps in analyzing geophysical problems, wave propagation in soil, and even large-scale environmental modeling. The real power of physics lies in recognizing symmetry. When you align your coordinate system with the natural symmetry of the problem, mathematics becomes elegant and solutions become more intuitive. In essence, physics teaches us not just how to calculate, but how to think smart. So next time you face a complex engineering challenge, remember, don't just ask what are the equations. Ask instead, what's the symmetry, and which coordinates make it simplest. This video is part of the series Physics for Engineers, Foundations that Build the Future, an initiative of Physical Sciences Consultorium. If you found this useful, don't forget to subscribe for more content, and explore our channel for videos that connect physics to real-world engineering.